let us explore detection limits. So every method has some limitation on what it can do. Some methods have a very high detection limit, as in it's not capable of detecting very small quantities of the analyte, and some methods have very low ones. In fact, some fluorescence methods can even detect a single molecule. But for the most part, methods do have a detection limit that's bigger than just one molecule. And so how would we evaluate our detection limit? So let's look at a typical calibration curve. And so we're usually looking at something that would give us an intensity or a signal, sometimes is called. And then that would equal our sensitivity, which is the proportionality constant or the slope of our calibration curve when we plot concentration versus intensity, which would be multiplied by concentration plus whatever our blank is measuring. Now, this blank sometimes gets thought of as a little bit of an afterthought, but this is very important, especially when we talk about variability in our blank, because this is really going to determine how low of a concentration we can detect. Because if I have a blank that is all over the place, that's kind of noisy, and that will make it so that it's difficult to say that that signal that I'm measuring is from analyte, or is it from something in the blank or some variability that just exists in the method. So if we actually look at the variability in the blank, that comes into play with the detection limits. So really, what do we mean by I know for sure that there's analyte in this sample? Well, I need to know that there's a signal beyond the blank, right? Higher than just the blank. And if I see that, and I know for sure, yes, this is higher than the blank, then I can say there is analyte in this sample. So I have my blank, and then I'm going to add some amount of signal beyond that. And this is actually based on the variability in my blank. So here's the standard deviation of the blank, and then I'm going to multiply it by some number here because I want some amount beyond just the blank, right? Because there's variability in what the intensity of this is, so I need to know for sure, no, this is beyond that variability. So here's this particular amount, and let's go over a couple of different multipliers that we could use to, and what those would actually entail. So if we say 3 times the standard deviation in the blank, then we're able to say, yes, there is definitely, or probably, analyte in this mixture. There's a pretty good chance of that. So this would be more like the limit of detection. Now, it's going to be very difficult for us to say how much analyte is there, only that there is some detected, right? And once we get down to the limit of detection, there may be analyte there, and it may be of a concentration that we should be able to detect. But it's possible, if the blank is somehow measuring a lower value, that we might not be able to distinguish that from noise. So some of the time, even at the limit of detection, we may not detect the analyte if it's of a sufficiently low concentration, right at the detection limit. Now, perhaps we don't want to just be able to say, yes, there was analyte in this sample. We want to say more about it, like actually know the concentration of the analyte. So in that case, we would use 10 times. So if we multiply the standard deviation of the blank by 10, then we'll have the limit of quantification. This is the smallest value that we could easily say this is the concentration of that analyte. So that's a consideration when we're trying to measure something or actually make a determination. If we're very, very low concentrations, effectively that is saying we're going to have difficulty distinguishing that from a sample that does not have analyte in it. Now, when we get up to 3 times the variability in the blank, or the standard deviation in the blank, we should be able to say, no, there might be analyte here, there might not, but there's a better chance that we'll have some confidence in that. And then if we go up to 10 times that variability, we should be able to say, this is the concentration of our analyte in there, and have reasonable confidence that we have a good number on that.